We're going to continue our work with trigonometry. We're going to talk about angles, a little bit more on angle measure and what we do with angles in the Cartesian coordinate plane. So here's a triangle with angle theta. And this triangle has an adjacent side to theta, an opposite side to theta, and a hypotenuse. Remember, the hypotenuse is always opposite the right angle. So we take this triangle and we put it in standard position. Standard position means that our vertex, that is angle theta, is at the origin. Our right angle sits on the x-axis. And we have a radius of a circle. Here's a circle in the plane. That's why this is r. We know that any horizontal measure we call x, and any vertical measure we call y. So where x and y meet in the Cartesian coordinate plane is this point P. And it has x coordinate for the horizontal distance from the y-axis and y coordinate for the vertical distance from the x-axis. And here is where we get all of our trig functions from. We're not actually going to cover the trig functions today. We're going to talk about reference angles in the plane. But this is all based on what's happening with a triangle in the Cartesian coordinate plane. So just as a reminder, the reason that we number these quadrants and care about which quadrant our angle is in is because the xy coordinates in the plane play a big role for sine and cosine, and therefore for tangent, because tangent is sine over cosine. We know that all coordinates in quadrant 1 have a positive x coordinate and a positive y coordinate. We know that all points in quadrant 2 have a negative x coordinate and a positive y coordinate. We are on the negative end of the x-axis here, the positive end of the x-axis here. And both of these quadrants, we are on the positive end of the y-axis. In quadrant 3, both coordinates, x and y, are negative. We're on the negative end of the x-axis and the negative end of the y-axis. And finally, in quadrant 4, we're back to the positive end of the x-axis, but still on the negative end of the y-axis. So we know some things about the coordinates of points depending on which quadrant we're in. And that plays a role for us when we find our sine and cosine of theta in the plane. So that's a little bit more work on our quadrants in the Cartesian coordinate plane. What we know is that if we can locate a point, let's say in quadrant 1, and we know the coordinates of that point are x, comma, y. When we take that point and we reflect it 90 degrees over the y-axis, we know exactly what the coordinates of its reflection is going to be. We're on the negative end of the x-axis, positive end of the y-axis, and so we're going to have the exact same numbers, whatever these numbers are. Let's say this was the point 3, 3 in the plane. We would know that it would map or reflect over the y-axis directly to the point negative 3, 3. If we took this point and reflected it the same distance over the y-axis, we know the coordinates of that point. That would have to be negative 3, negative 3. And again, if we reflected it back over the y-axis, we know the coordinates of this point. Positive end of the x-axis, negative end of the y-axis. So we're going to use that when it comes to filling out what's called the unit circle. But first, let's take a quick side tour here and talk about reference angles. This says let theta be an angle in standard position. The reference angle, now the notation used here is not a common notation. I'm not sure what textbook that came out of. Here's the notation we're going to use. It's theta, that Greek letter that we're going to use to mean angle measure, and we put an apostrophe after it, and that's called theta prime. So this is theta prime. And theta prime stands for the reference angle to some angle that we're given in the plane. And it is associated with the original angle measure theta, and theta prime will be the acute angle formed by the terminal side of theta and the x-axis. So if we're looking for a reference angle, we've got to be given an angle measure and find the acute angle between that measure and the x-axis. And that will be our reference angle. So let's look at some examples. And again, we're going to use the theta prime notation, theta prime. This notation is not the notation that I want you to use. But I could not, for some reason, find exactly what I was looking for with the prime notation. So when you take your notes, make sure that you're using theta with the apostrophe. So to find a reference angle, theta prime, it's useful to know the quadrant in which the terminal side of the angle theta lies. Here's one for quadrant 1. And so if this is theta, then the measure between the terminal side of angle theta and the positive x-axis is theta prime. It's our reference angle. So it turns out in quadrant 1, theta will always equal theta prime. In quadrant 2, we're going to be closest to the x-axis at pi, or at 180 degrees, right now, whichever you're comfortable with. So we're going to find theta prime in quadrant 2 by taking 180 degrees and subtracting theta, or in radian measure, we would take pi and subtract theta, and that's how we would find the reference angle. In quadrant 3, we are going to be closest to the x-axis by taking 180 degrees, or pi, depending on your measure, and adding the theta angle measure. And let's see, is that correct? So this is 180 minus, okay. So we need to do, oh, I'm doing that backwards. Sorry, let's start this again. In quadrant 3, we're going to take theta and we're going to take 180 degrees out of it. And, or if we're in radian measure, we'll take theta and subtract pi. And that's going to be the measure of this little angle right here, which is the reference angle. In quadrant 4, in order to get this reference angle, we're going to take 360 and subtract theta. So we take a full revolution and subtract the original angle measure out of it, or 2 pi for radian measure. And that's going to give us theta prime. So let's go back up here and look again. Remember, the reference angle associated with some angle measure theta is the acute angle formed by the terminal side of that original angle and the x-axis. So that's where all of those come from. So let's see, let's make sure this is all in your notes. So there's theta prime in quadrant 3, depending on how you're measuring, degrees or radians. Here's theta prime in quadrant 2. Theta prime in quadrant 1 is theta, and theta prime in quadrant 4. So finding reference angles. Here we have theta equals 5 pi over 3. So the first thing we've got to determine is what quadrant is that in. So 5 pi over 3 is in quadrant 4. So in quadrant 4, and we're in radian measure, we're going to take 2 pi and subtract 5 pi over 3. And that's going to give us theta prime. That's going to give us that acute angle measure that is a reference angle for 5 pi over 3. So this is with a common denominator, 6 pi over 3 minus 5 pi over 3 equals pi over 3. And that is an acute angle. That's equivalent to a 60-degree angle. So let's look at this one here, and that is what we got. For the 870 degrees, let's talk about our angle. Here's 360, here's 720, and 720 plus 90 gives us 810. So we're back here. And if we wanted to add, let's say we need to add another 60 degrees. So roughly about right there is going to be 870 degrees. So here is our x-axis. We want to take 180 degrees, and we could do an equivalent starting here and going there. So that would be 870 degrees minus 2 times 360. And that would give us this angle measure. And we can, in quadrant 2, take 180 minus that angle measure. So that's 870 minus 720 is 150. And I do see that's where they wound up down here. So we're going to take 180 minus 150. And so our reference angle for this angle would be 30 degrees. So not difficult. Just got to figure out what quadrant you're in, how many rotations you've made, and how you're going to find that reference angle. And it all has to do with the horizontal axis. All has to do with the x-axis. So that's all we're going to talk about today. Come to class next time and we'll work some homework problems.